In an earlier episode of OpsTalk, we talked about task automation. As CloudOps teams chase automation, one sobering thought stands out. Automation works for predictable, routine tasks, but you can't predict every single scenario, and therefore automate just everything. So how do you deal with such unforeseen tasks on the fly? This is the question we're addressing today. Sysadmins and DevOps frequently need to get shell-level access to their EC2 instances precisely for such tasks on the fly. The on-the-fly tasks can be for routine maintenance, or more often than not, for serious break-glass interventions. Getting shell-level access to servers remotely can be surprisingly complicated, cumbersome, and error-prone, sometimes exposing security holes in your infrastructure. Thank you for joining the sessions of OpsTalk podcast. I'm Rick Habley, and with me is Luke Walker, Head of Product Management at MontyCloud. Today, we discuss why it's worth the effort to simplify the process of getting shell-level access with one click. Luke, welcome to OpsTalk. Thank you for joining.
Thanks, Rick. Great to be here.
Okay, this might sound a bit oblivious, but haven't compute infrastructure, operating systems, management tools evolved enough that you don't need to get shell-level access to compute nodes anymore? Why do IT admins and DevOps engineers still require shell-level access to their virtual machines, even as they use immutable infrastructure?
Well, Rick, while organizations are starting their journey to more deterministic builds, so environments where systems are built and deployed to a standard and configuration management is automated and catered for, the ability to directly log in to a target server and look under the hood while it's in operation remains one of the most powerful tools in the CloudOps engineer toolkit, just like a screwdriver may be. Even when you're managing a large server fleet with config management tools, something as simple as an inadvertent change can result in a bad system state, and you need to break glass to determine what the change to the config is necessary.
Having to break glass is quite the dramatic moment, but it sounds like you still see this frequently occurring even in the most robust environments?
More than many realize. One of our customers, LeadSquared, they're a marketing automation platform powered by AWS, and they ran into this very scenario not too long ago. While the application is generally well managed, they pushed out a change that inadvertently caused the guest operating system to deny access to critical application traffic for about 20 minutes. In most cases, you would roll back to the last known good configuration, but in this instance, the only way to recover was to get shell access and directly remediate the application and supporting frameworks.
I just hope this is incidental in such a scenario. Why wouldn't one immediately write a remediation script to prevent this in the first place?
It's every ops dream to be able to write that one single master script that does everything, including brew coffee. But the reality is LeadSquared did not anticipate that routine software update would result in the guest OS denying access. And not every scenario can be automated ahead of time. Well, maybe with the exception of brewing coffee, that has been done, but I think you get the picture here.
If only my own coffee would just magically appear at my table. But given we're talking about direct access to a VM in this age of automation, data collection, and AI, there's reason why direct access is an overlooked important piece of the OpsTalk toolbox.
Absolutely. While inadvertent config drifts are one reason why you would want shell access to a virtual machine, it could also very well be necessary to directly review an application and server logs, fine-tune a configuration, or even just terminate a runaway process. These are not always tasks best suited to automation or your remediation scripts because they still require the human in the decision-making process.
You're saying planning for failures still doesn't mean definitive automation and process. In effect, you're nowhere without humans holding the right tools. So what makes this so difficult that we're even talking about it right now? Surely logging into a server is easier than it was pre-cloud?
Surprisingly, providing secure, robust remote access into one's infrastructure can be time-consuming, or it presents several operational security risks. So as you set up a well-architected Amazon application environment with a blueprint, one of the core tenets that you're trying to address is security. You need to ensure that you are establishing controls, you're protecting systems from attack, but in order to be able to observe and react to an incident like LeadSquared's, where human interaction is still required, you need secure access into those target EC2 instances. And for most people today, whether you're in AWS, you're in Azure, or an on-premise environment, that means that you have to create a secure path using Bastion hosts or a VPN, managing SSH keys, or an agent-based management approach. All of these mean more infrastructure, which then again equally must be secured and well managed. And while the remediation scenarios are clear, it's been interesting watching how difficult some of these steps can be. We're working with another customer who has an environment just for data science. And time again, one of their top 3 support tickets is just to regenerate SSH keys that have been lost or misplaced by users. The very users authorized to access instances within the environment to get access to the core data.
If I get you right, that's really no different than having to replace the keys to my house every week. A security nightmare. In a more controlled environment, I'm sure that this may be better managed, but especially with the majority of us working remotely in these extraordinary times, how exactly would you go about secure access?
Sometimes it just takes a fresh look at the environment to find a better way. Recently, MontyCloud shipped a feature that extends AWS Systems Manager's Sessions Manager service. I get it, that's quite the mouthful, but leveraging Sessions Manager with the Day2 platform, we can now open shell access directly into Windows and Linux, yes, Windows and Linux, EC2 instances in a single click. So you're a customer, you're trying to provide access for your operations team, you don't have to build all this additional security infrastructure that you would have had to in the past, or that Lead Square's had to build, or in other accounts we've seen time and time again. So this means no more Bastion hosts, no more VPNs, no more losing your SSH keys or your keys to the environment. It's straightforward single click from a web browser and you're right into a PowerShell session or a shell prompt.
If something almost sounds too simple to be true, you'll have me looking for the catch. I mean, remote access usually, in my mind, means directly connecting to a host. So how is this different and how do you keep it secure even?
So the interactive shell sessions are very secure because our Day2 platform works in concert with the Sessions Manager endpoints. So we're talking securely through to AWS. AWS then has a secure method to talk through to the Systems Manager agent bundled by default on nearly every Amazon image. So whether you're using a stock standard Server 2019 for an Amazon Linux 2, or you've built your own AMI, but it's based upon an Amazon standard, you've got a Systems Manager agent, which means that you can have instant remote access to your machines without having to deploy anything additional. And on top of that, because it's been handled through an Amazon service, that instance can be deployed with no inbound rules. We get we ensure a secure path to gaining shell access through the service. We don't have to create a backdoor straight through your security group per se. And then in addition to a secure path for Day2, every one of these sessions is logged. That's very important because you want to know what's been happening on these console sessions. So every command you write, the output that you receive back, all of this goes directly into a CloudWatch log trail and retained for 30 days. So not only is it recorded, these details, these session details are kept off host from the original server and secured away in case they need to be inspected.
So that's all of the access with none of the trade-offs. You still get to keep that powerful tool in your toolbox, and you get to make your infrastructure more secure by not having to build any special or crazy backdoors.
Correct. CloudOps engineers and even myself want to avoid creating a complicated environment. And to do that, you want to avoid being forced into making trade-offs between responsiveness and security.
Given that you are leveraging AWS services here, what does Day2 add to Sessions Manager? Can I not directly use Sessions Manager to do the same thing?
That's a fantastic question, Rick. Now, there's two parts of the puzzle to gaining secure access here. There's the configuration aspect, and then actually gaining access itself. Where Day2 shines is by simplifying both of those processes, and seeing is believing, so I'll just go ahead and show you. Day2 makes the entire process of configuring Systems Manager very straightforward. So activating the agent present within the EC2 instances is a simple task. So whether it's one instance, 10, 1,000 instances, I can go ahead, select those nodes, convert it to a managed task, and Day2 will go ahead and coordinate with Systems Manager to get the IAM roles configured. Agent activation has to be submitted through. and then processed accordingly. Normally, this is quite an onerous process. Now, once those hosts are under Systems Manager and Day 2 management, now we can see all of the server fleet across all accounts, all regions within a single pane, which means that we can then gain shell access directly into a Windows or Linux host with a single click. So within the infrastructure page on the portal, there's a remote console option directly on that interface next to each of the servers that you can see here. And in a single click, up pops the shell prompt, and we're in.
That's really amazing to see in action, and you talk through it. You said this remote console functionality is GA, right? Can I test it myself?
Yes, this is base functionality for Day 2. So you can sign up a free trial today via our website, MontyCloud.com, or if you're already a customer, just log in with your account, and by accessing the infrastructure pane, you'll see the remote console option for any managed instance that you've discovered within your attached cloud accounts.
Thanks, Luke. And it's worth mentioning here that more details are published on our OpsTalk blog at montycloud.com/blog. And I'd certainly recommend trying out this feature yourself. This also concludes today's OpsTalk. You can find more details on one-click shell access and other Day 2 automations at montycloud.com. Stay tuned for our next OpsTalk. Luke will be joining me again to talk about application cost management. Subscribe to get the reminder. And thank you for joining us today.